In today's video you're going to see my laser piano, a string of 88 lasers controlled by MIDI music files to create one hell of a light show.
Hello everyone and welcome back to the lab. In today's video I'm really excited to show you this, which is a project I've been working on for a long time. It's really impressive and it's just finished, and it's called the laser piano, for lack of a better name, because that's basically what it is. It is a bank of lasers that you can see along here, and it is controlled by MIDI information either from a computer or from a keyboard, such as this MIDI keyboard here. So I came up with the idea for this all the way back sort of at the end of 2016, so quite a while ago, nearly 2 years now, although not as old as some of the projects. The Fuser, which I was talking about a few videos ago, I actually started that about 5 years ago now, so not that old, all things considered. So the idea was, a year before then, 2015, I wanted to make a project that wasn't just interesting to make, wasn't just electronics, but was also something that people could look at and think, wow, that looks cool. Like the Tesla coil, like most of my projects to be honest, but I had an emphasis on sort of making a show. I'm not going to go into the details of it, but I wanted something I could show a group of people that mixed electronics and science, and I thought the best way of doing that is music, because I like music as well, and there's all sorts of ways you can combine electronics and music and science together, so I thought let's do a simple project like that. And I ended up doing something around what's called cymatics. Now, cymatics is basically it's a way of visualising sound. There's all sorts of cymatics experiments out there that you can see online. There's some really good music videos put to them. You can have a look at those. But the idea is using things called Chladni plates or Rubens tubes or anything like that. You can look up what those are, but those are ways of visualising sound using science and physics. So I thought I'd do something like that. And make it basically almost like a performance and show people this experiment running. And the thing was, it worked very well in practice. But the issue was I wanted to make this something I could show people live. And when things are live, things don't always go to plan, and they definitely don't always work first time, and if something's live, it has to work first time. Without going into too much details, because that isn't the focus of this video, let's just say I had some cymatics experiments, but the problem was the frequencies of the sound required to get these cymatic effects that look cool, that people want to look at, are different to the frequencies of the music that's being played. So what you had was a song being played and a bunch of frequencies that generate these really cool visual effects. But of course they're not the same, so you have this horrible, disgusting sounds playing whilst music's playing, and it kind of ruins the entire effect of it. Whereas if this was in post-production, you could just edit that out and you could just have the music. So suffice to say, that experiment wasn't really a success. And there's various other issues with it, but like I said, I'm not going to go into it. Now, it's one thing having a project that fails and a project that doesn't work and a project you have to scrap. It's another thing if it was designed to be something to show people, something people were expecting to see, and it doesn't turn out properly, because then you've disappointed a bunch of people. Now, in the end, it turned out okay, but just nowhere near as good as it could have been. So that failure kind of pissed me off a bit, so I was like, right, let's go back to the drawing board completely, and let's completely redesign something new, something completely different, that visualises sound similar to the way cymatics does, but something that will definitely work and definitely work live and will definitely be cool to show people. And so this was born, the laser MIDI piano, or MIDI keyboard, laser keyboard, whatever you want to call it. So it's exactly what it sounds like. There are 88 lasers here. There are 88 keys on a standard keyboard. This is a small one. The bigger one I have isn't a MIDI keyboard and doesn't have USB, so I can't connect that up. But the idea is that each of these lasers corresponds to one note on a piano, and you can either play a keyboard or a piano plugged directly into the device, or you can play a MIDI file, a MIDI song, from a computer and it will play it in the lasers. And of course that is pretty impressive if you have one of those really fast impossible MIDI remixes playing through all of these lasers. and it does look really good, and I'm really happy with the results. In the previous video I talked about the smoke machine, and I showed that off. The smoke machine itself isn't very impressive. I mean, it doesn't even fill the room fully, it just makes a haze in the room, but that's plenty enough for you to completely see the beams of this. To best show this off, what I'm going to do is I'm going to release a series of videos, each one doing a song or a couple of songs being played on this, some fast, some slow, some with loads of flashing lasers, some that people will know, some that people won't. I mean, I've been messing about with this for a few days now, and honestly I could spend all night playing different MIDI files through it and generating different effects, as well as writing your own, because this whole system is entirely programmable. So there's a million more different things you can do with it, but for now I'm just going to try and get some of those videos out there, and then later on when I come up with more things to show, I'll make videos on that. And of course, if you want to suggest a MIDI file to play, just put a swing in the comments, and if you don't have a MIDI file, I'll try and find one for that song. But the results of this are pretty cool, especially with the smoke machine. So I'll show you a little bit in this video, but primarily there's going to be a ton of videos uploaded after this, featuring different songs. But first of all, let me just quickly show you the hardware, because it's not actually too complicated or technical. So now, I've never actually seen anything like this online before. When I was first coming up with ideas, I was thinking about, okay, what could I make that was similar to cymatics that allows you to visualise sound and music in a cool way and involves electronics. So I first came up with the idea of lasers because I'd used a laser in my cymatics experiment. I had a laser pointed at a bowl of water that was connected to a speaker. The speaker would resonate at a specific frequency that would create this really cool ripple effects in the water. That's the cymatics part, and the laser would reflect off that, and of course that would make the laser beam shine all over the place. And that part did look okay, so I used that as a starting point. So I thought, what could we do with lasers that looks cool? So I had a think, and one of my first ideas was to actually have a bit crazy, to have lasers rotating all over the place. So there would be like a wooden pole or something in the middle, and then a laser connected to that with a motor in the middle. And then around the outside, there'll be some sort of wooden structure, ideally circular, but I'm not sure how I would actually achieve that. And then the laser, as it rotates, would almost shoot beams around this thing, making this circle. And if I had this laser on a servo that was spinning back and forth really fast, it would look pretty cool. The issue with that, though, is that the notes in a song obviously play a lot faster than a servo could rotate, which means this would lag behind. It would be completely out of time with any kind of music, it would look rubbish. So that put me off that idea. Then I thought, hang on a second, maybe I can expand this. So I thought, making it almost 3D and having a set of lasers that would all, shoot beams out around the circle, and they could have them different colours. And that would obviously increase the effect. But you would have the same problem, because eventually, if you have a really dense MIDI file with 10 notes playing at once, that's still not going to be able to catch up. And programming it's going to be an absolute nightmare. So I scrapped that entirely. I just kept the lasers and thought, well, why don't I just make it really, really simple? Why not just have one laser for each MIDI note? Now I know there's technically 128 MIDI notes, but most songs don't even use that range. You can see how long this is, it just fits onto the camera. 128 would be double this. And from the MIDI files I've played, nothing even uses outside of this range. The majority of songs pretty much are in there anyway. Very few use the very end ones. When I was looking for inspiration, I wanted to see what people had done before, and I hadn't seen anything like this before on YouTube. I've typed in, laser controlled MIDI pianos and stuff like that, and there's all sorts of things with lasers flashing, but nothing quite like this with a laser for each individual MIDI note. I have seen things where there's a laser harp where you can control MIDI notes by breaking lasers with your hands and using light sensors and stuff, but I wasn't really interested in making like an instrument you play. I was more just wanting to make something that would just present a show. It would be something to look at. You wouldn't have to do anything, you just click play. I came up with the design myself because, like I said, there was nothing out there that existed like this. The problem being that there's 88 lasers is that how do you interface to all of those lasers? Now, I'm a massive Arduino advocate. Anyone who knows me knows that. I have a bunch here. Here's just an Arduino Nano, and that's what I'm using for the heart of this. The problem is there is not enough pins on this to connect all the lasers up. If you don't know what an Arduino is, it's similar to a Raspberry Pi, but it's just a programmable, really cheap, really small, simple microcontroller. You can program it in C++ from a computer, and you can connect anything electrical up to it as long as it's within the voltage range and you can control anything from it, basically. It's how I do all my projects now. But there's not 88 pins on this, you couldn't connect 88 lasers up to it. Even the Arduino Mega has something like 60, so it's close, but it's not there. So the first obstacle was to find out how I can have more pins, and the answer to that was shift registers. Now shift registers, all they do is they basically output data in serial. So the Arduino gets the information for each of these virtual output pins, sends them to the shift registers, and then the shift registers have the individual pins onto them. And because it's sent in serial, it only needs one data line. So actually the Arduino Nano here just has one data line coming out of it to these 11 shift registers. And each of these shift registers has 8 output pins, one for each of these lasers. And then there's a few wires for power, a few wires for ground, stuff like that. But that's it, that's all there is. It's just the same thing repeated over and over again. The Arduino just connects to the computer or the MIDI keyboard via USB, very simple. Now the hardware on the actual lasers themselves, there's a resistor and a transistor for each laser. The resistor is there because laser diodes are current hungry. They will burn themselves out. I've had that happen a few times, so the resistor is there to limit current. And the transistor is there because the Arduino itself cannot output enough power for all of these lasers. Instead, they're just control signals. And the control signals come from the Arduino, they trigger the transistors, the power comes from a cable that's plugged in on this end, you can't really see, but that just goes to a power outlet on the wall, DC adapter. And that powers these rails that go across, and that's where the lasers get their power from. Again, it's quite simple, it's just I had to do it 88 times. So 88 transistors, 88 resistors, 88 lasers, and of course 88 control lines coming from all these shift registers. So it was a hell of a lot of repeated soldering. The base design was there, it was just a lot of work doing it, a lot of labour basically. They're all connected to this here, which is just a PCB, which I've connected all the shift registers on, and the Arduino.
For software, there are 2 programs running to get this to work. MIDI note events are generated from a MIDI keyboard or from a MIDI player such as Synthesia. The note number is extracted from the MIDI data in a small program I made in processing, which also sends the note number to the Arduino over serial. The program running on the Arduino simply uses a shift register library to turn the laser corresponding to that note on or off depending on its current state.
So going back to the design of it, originally I wanted to have different colours. It would be a simple green, red, blue, repeated all the way along. Like I just said a second ago, if I tried to have RGB for each individual note, that would mean 3 times as many connections and hardware as there is here, which would be an absolute nightmare to wire, not to mention it would be 3 times as expensive. This wasn't too expensive because the lasers are bought, loads of them really cheaply from China, and they do work, for the most part anyway. I had to replace some of them. So that was fine, and resistors and wires are fairly cheap, but it's just the manual labour of all that really. That was the killer of this project. But the problem with lasers is that you would think getting a different coloured laser would be the same price as any other. You know, maybe like paint. You know, green paint is not going to be any more expensive than red paint or blue paint. But it's not quite like that, because the lasers work using crystals. And the crystals required to generate different colours, because it's all to do with excitation and de-excitation of electrons inside the crystal and stuff like that. The crystals required cost different amounts to obtain or to generate, and I think in some lasers, I can't remember if it's blue or green, they actually have to have multiple crystals and they have to have different electrons ionising and exciting and de-exciting between these crystals in order to generate that specific wavelength for that colour, because remember, that's how the light is generated. It's just excitation of electrons in electron shells at specific frequencies, generating specific wavelengths. Now, the reason why you see red laser pens all the time is because red are the simplest, the cheapest and easiest to manufacture. The different colours require these different crystal setups. So to actually put RGB lasers, even if it's just one per MIDI signal here, it would just be a lot more. I looked into it and it would be like 3 to 5 quid for a green or a blue laser, whereas I can buy, 20 red lasers for that same price. So that didn't happen, unfortunately. So what I'm going to do now is I'm just going to plug in the USB into a program I've written that just counts along showing the lasers. And when you first plug it in, they do all, well, some of them do turn on randomly until the system gets itself in order. Now, of course, you've got to remember, this entire system is programmed by an Arduino, which is fully programmable in C++, so you can actually get this to do whatever you want. It doesn't have to be anything to do with MIDI files. So a program I've loaded onto it right now just counts along. I use this for testing purposes when I was replacing lasers, because I needed to find which ones are damaged and which transistors weren't working. So what I can do is I can actually just speed this up a lot, so you can already see what the effect will sort of be like. And I'll speed it up one more time. So now there is a delay of 10 milliseconds between each of the laser pulses, so it will go along pretty fast. So now that you can see it working, it's time to show you it actually perform by playing MIDI files. So first of all, I'll show you using the keyboard, just to demonstrate that, and then I'll show you it actually, I'll show a few clips of it playing MIDI files from the computer, just so you get an idea. And like I said, the videos I'm going to be releasing in the next couple of days and the next couple of weeks will be actual full-length songs, not quite in the dark, but the whole system will be in the dark with the smoke so you can see it properly. The reason why I don't want to do it in pitch black is because the camera doesn't focus very well. So you can see the lasers, but they're a bit blurry, and I've actually found that, to be honest, it looks a bit better when there is a bit of background light and you can still see the room, which sounds a bit counterintuitive because you're trying to see the lasers, which are themselves a light source. But let me know in the comments what you think's best. Should it be in pitch black or should it have a little bit of light? I'll show you both of those clips afterwards. Okay, so I'm just going to quickly turn on the smoke machine, just add a bit of smoke in here and lower the lights a little so you can see this a bit better, and then I'll show you it's actually in effect. Well, anyway, you get the gist. But I'm not really one for playing the keyboard, so I think we'll let the computer take over now and really show you what this is capable of. video. I hope you enjoyed. Like I said, what you saw was just a very short demo of this. There's going to be a ton of videos coming out hopefully this week and some more later on in a few weeks' time, showing a whole bunch of songs played on this, where you can see the full length of the lasers, a lot darker and with a lot more smoke, so you can see the full beam properly. But yeah, I hope you enjoyed, and please send me a MIDI file or suggest a song if you want to see a full song played on this. Or if there's a MIDI file for it, I'll certainly do a video for you. Okay, well, look forward to much more videos coming out very soon. There's the blog posts where you can see pictures of the construction of this and the construction of all the other things, all the other projects which aren't shown in these videos. Links in the description. Alright, see you in the next video.